All right, so I'm just gonna go through this worksheet that you had to do for Monday. So looking at the first question, you got a line graph. It's talking about the number of figurines and the time in months. So Tracy collects, sells, and trades figurines, and she tracks how many she has in her collection on this chart. So kind of reading through the chart, you can see like, okay, she's got a certain number of figurines. She collects up until month one, and then between month 1 and 2, that her collection goes down. So she's trading them or selling them or something. And then she collects, and then trades and sells, and then collects. So the first question is, during what month is the number of figurines in Tracy's collection at a peak? Obviously, that's at month 5. So between which 2 months are the figures in her collection increasing the fastest and slowest? So we got to look at basically 3 little sections where the graph is actually increasing, because the other sections it's decreasing. So I just want to look at those 3. So which one is it increasing the fastest would have to be where the slope is steepest. That's between months 4 and 5. And where it's increasing the slowest, between where the slope is the most flat, which would be between months 0 and 1. So that would be the answer to that first one. Number 2, you got a chart talking about adults contracting colds, given sugar pills, given vitamin C, and so on. So you can read through it, but basically the chart tells all pretty much. So how many people surveyed got a sugar pill? It's pretty simple. You look at total of 100 people surveyed, 150 of them got a sugar pill. What is the probability you got a sugar pill and got a cold? So you got a sugar pill with a cold, that's 33 people out of the total of 300. So that's my probability. What is the probability you got vitamin C and got a cold? Would be 21 out of 300, so 7 out of 100 chance that you're going to get vitamin C with a cold. So a little bit better. So it looks like vitamin C does a little bit, maybe. This is percent of people in the entire study that got a cold, right? So you talk about like how many people got a cold. It's 54 out of the total 300. So that's about 18% of the surveyed people got a cold. All right, so that's page 1. Page 2, moving on. Whole page 2 deals with these 2 charts. One of them is talking about the growth factor of certain trees, and then it gives you a scatter plot that we'll talk about in a minute. So the description says one method of calculating an approximate age in years of a tree of a particular species is to multiply the diameter of the tree in inches by a constant called the growth factor. So the table above gives the growth factors for particular trees. So basically, like, I just wrote this formula down. The age of a tree is equal to the diameter times the growth factor. So it says a white birch tree has a diameter of 20 inches. How old is it? So you look at white birch has a growth factor of 5. So if I take this formula and say like age is equal to diameter times growth factor is 5. And it's about taking information from a chart and being able to interpret it. So 20 times 5, pretty simple. You can see that tree is going to be about 100 years old. A red maple has a diameter of 6. What is its age? So red maple, growth factor is 4.5. So 6 times 4.5 is a 27-year-old tree. So part C, it says you planted an American elm tree in your yard. What would you expect the diameter of the tree to be after 20 years? So this is kind of like using the formula in a backwards way. So if age equals diameter times growth factor, and it tells you want the age to be 20, diameter and growth factor. I know the growth factor of an American elm is 4, so 20 equals diameter times 4, so just divide by 4. Diameter would be 5 inches. So pretty straightforward question there. This last one is a little bit trickier. So the question says, for the scatter plot to the right, using the growth factor table, which tree species do you think the samples came from? So looking at this problem, I said in my description, I said, look at a few points. So what I mean by that is I say, look at a few points. So if I look at like a 100-year-old tree, I could track that down and see like, yes, it's about, if I think about like a line sort of like right down the middle here, right? You could kind of see like, okay, so a 100-year-old tree, if I was being pretty honest, is about somewhere between 13 and 14 inches in diameter. So I did that one, and using the formula, if the tree is 100 years old and the diameter is about 13.5 inches, I determined that the growth factor for that tree was 7.4, right? So I was like, okay, so out of these choices, I'm kind of moving around a lot here, so if you want to pause at any point, feel free. But out of these choices, you're like, it's got a pretty big growth factor. There's no other growth factors that are even close to that 7.4 other than shagbark hickory. But just to be certain, let's look at another point. So I took a point all the way at the top. So looking back at the table, this scatter plot we're looking at, if you follow this 130 across, it's like about 16, maybe 16.5. I said 16. So let's just go back to here. And I said like for a 16-inch diameter tree is about 130 years old. That gives me a growth factor of 8.125. So again, you're the biggest possible growth factor out of all these growth factors. So it has to be a shagbark hickory. So it's kind of reading through these, and chart reading and all this stuff is a very important skill. Hopefully this is pretty easy, and hopefully this video helps.